Welcome to our tech talk on 3D printing. Hector Arzola, our Makerspace coordinator, is here to chat with you all. And I'm going to just turn it over immediately to Hector.
Hi, everyone. Hope you're all doing well. Today, we're going to get into a little bit of the basics of 3D printing and some modeling. So we're going to talk about some of the software that you can use and have a little run through about an easy, accessible, and free software that is cloud-based, and it's TinkerCAD. So if you think modeling is kind of intimidating, we're just going to run through just modeling something basic so you can kind of see the idea of how it works. And then these concepts can be applied to more advanced softwares like Fusion 360 or AutoCAD or even Blender if you wanted to go to a more artistic and not a very like specific software that's more precise. So let's get our slides started. Okay, so what is 3D printing? One of the earliest 3D printers was introduced back in the 80s. In 81, Charles Hull got a patent for an SLA printer, which nowadays has a very high resolution quality, great printers. But what we're going to focus on is the ones that we currently have in the system. 3D printing is an additive manufacturing process that creates a physical object from a digital model file. So that means any file that you have, either you created or just downloaded from online, as long as it's an STL or OBJ, you'll be able to import it, slice it, put all the parameters and settings for it, and then have a physical object at the end. And the way that that happens is it lays down layer by layer. Plastic gets melted to a certain point, depending on the material. It could be as low as 185 or as high as 250 degrees. It melts the plastic, extrudes it from a nozzle, and then lays it down layer by layer, kind of like laying down cards, playing cards. Each would be a layer, and it'll make that 3 dimensions. So what are some of the applications? It's not just to make trinkets and little sculptures, but you can also use it to educate, to teach how to do design applications, engineering, all those kind of designs. Of course, you can make art. It's also applicable in the science field for medicine. Dentists use it. You can make prosthetics, and they're looking into making printable organs. So some of the common 3D printers, SLA and FDM are the most commercially used. SLA printers go through a process of curing resin. So UV light cures the resin and it prints from upside down. So as the build plate rises from a vat of resin, the light cures it and it gets solidified, and then it moves on to the next layer. It's a bit slower. It has high resolution. So if you're wanting to print minis or pieces that have to fit perfectly together, that's something that you might want to use. SLS printers kind of do the same thing, but they use a laser to fuse polymer powder. This creates a lot of waste, but it does not create, it doesn't require support structures. And then FDM, which is what we're going to be covering through most of this presentation, is fused deposition modeling, which melts thermoplastics at a high temperature, extrudes them through a nozzle, and then successively lays them down layers. The thing with this one is it's great for beginners. It does have low cost materials. Usually a kilogram of filament is about like $20. It could be more expensive depending on what kind you can get. Like you can get wood infused fiber with PLA. You can get glow in the dark. You can get magnetic filaments, all sorts of stuff. It does have lower resolution, and the size of your nozzle also affects that. So how does it work? So filament, usually in the back of your machine, is on a spool. It's extruded through a feeder, and depending on your machine, it could be a direct-to-dry feeder, which will be closer to the hot end, which is great for elastic things like TPU. And some of them are a Bowden tube mechanism, which is closer to the filament, and then it's guided by a plastic tube. So after it goes through the feeder, it'll go onto the hot end, and then the hot end increases the temperature of the filament to the precise temperature depending on the filament, which could be a variety of things. From there, it'll go onto the nozzle and then onto the print bed. Some print beds are heated, and some are magnetic that you can just remove. And there's also things that you can help with adhesion if you're having troubles, which we'll kind of get into a bit later. So 3D printers comes in many styles, brands, experience levels. Prusa and Creality and Ultimaker have great resources online, either by the community or by the maker. Some of them are open source. For the Prusa, you can 3D print your own replacement parts. It's open source, so you can go in there, grab some upgrades, and install them onto your printer by printing them yourself. The Creality is also one of the more popular ones. Some of these come in kits, which can lower the cost, and some of them can just come as a standalone. So if you're kind of daunted by building your own, you don't have to. It'll increase the price a bit, but you'll know you got a well put together machine. At the central location, we have an Ultimaker S5, which has a bigger build plate. The other regionals have a Ultimaker 3. And so we're going to be covering those. Filaments. So filaments are vital for the 3D printing because that's what the materials are, what your object will be made out of eventually. So filaments used in 3D printing are thermoplastics. They are polymers that melt instead of they melt when burnt. So once it goes into the hot end, they'll start oozing from the nozzle, and eventually they'll solidify once they get cooled. What we use is 2.85 millimeter PVA, or PLA, that was a mistake. Yeah, PLA, which is polylactic acid. If you wanted to buy your own material, you can do 2.85 or 3. They're kind of interchangeable. And the pros for these, for PLA, it's affordable, it's easy to use. There's a wide variety of colors. There's some that you can even have in gradients, shifting from 2 to 3 colors. And they're less heat resistant, which this is kind of a con. You can't use it for any food application. So if you're wanting to make cups, you can't put it in the dishwasher. You can't leave it in a hot car. It'll start warping and oozing, and just, it can get a little messy. If you are interested in making it, in using this application for like Tupperware, glass, anything like that, you'll have to check with the specific vendor because different filaments are made of different composites, have different settings, temperatures, and yeah, you'll just have to verify with them. And yeah, here we have a couple of other kind of special filaments, like the color changing, if you want something to be more resistant physically and whenever you apply pressure to it. A flexible filament is TPU. Now, with some of the filaments, it can be a bit harder to print, either because it has trouble sticking to the plate, or it has trouble with blobbing, just different settings. So you might have to play with it before running a full print. Another really cool filament is glow in the dark. Glow in the dark comes in a limited amount of colors. The thing to know about that one, it is abrasive, so you might not want to use it with your regular nozzle. There are specialized nozzles like ruby tipped that are a bit stronger on the inside. So whenever it's extruding, it's not going to be wearing away at your nozzle. If it does, eventually your nozzle is not going to be the measurement that it's supposed to be. So either 2.4 or 0.2 millimeters, and it's going to be wider and it's going to mess up the print because it's not going to be as accurate. So 3D files, what are your options? One of the things you can do, one of the easiest ways, just download the files. There's plenty of websites out there. I just highlighted a couple. Some of them you would have to download. You can download for free. Some of them are paid for, like CG Trader. Some of the stuff on Colts is paid content. But the thing that I would recommend is Thingiverse. It's one of my favorite sites. There's a lot of different stuff you can get from there. There's also settings. So if you see the Rocktopus over here on the top left, it might require special settings or infill or resolution. So most of these files will kind of give you like advice on what machine was used, what kind of filament, what kind of temperature, and all those other settings. So the files that we're looking for are STL, serial lithography files, which are created specifically for 3D printing. These files are low in file size because they just have the information of like the mesh. They don't have anything else like the object files that can contain texture, color, anything else that you would actually use for like 3D modeling and applying it to like a video game or an animation, something like that. It's mainly just for 3D printing. And OBJ are things that you can get from like Blender, Maya, and other modeling software, which does have the more information about the mesh and the lighting and the shading and all that. So yeah, here's an example of a file from TinkerCAD. It shows you what it would look like as a model, a 3D model on your computer, and the finished product and the recommended settings for it. The cool thing about downloading these is that you can actually import them into whatever modeling software you have, and you can modify them. You can drop them into TinkerCAD and easily just scale them. You can also do that in your slicer, but it's pretty easy to modify your own files. And so the other option is to design them yourself. If you don't have any modeling experience, the thing that I would recommend is TinkerCAD. And I can kind of show you here in a minute. We can work through a little project together. We can make an animal. And most of these concepts can be applied to more advanced software with different options. So 3D modeling is a process of creating a 3D representation of any surface or object by manipulating polygons, faces, edges, and vertices. So I don't know if you can see it here, but every corner is the vertices, which you would be able to extrude. You can add more faces to make the resolution higher. And you can just kind of manipulate those areas by pulling them and pushing them until you get your desired file or object. So here, like I said, there's many software out there. Some of them are free, some of them are paid, some of them are aimed for beginners. So I'm just going to highlight a couple of them. One of the things available in the Digital Literacy Lab is AutoCAD. If you want precise files and measurements, that's what you would want to use. Also with SketchUp, it's more for a design and engineering concepts. TinkerCAD is a great basic file. It is from Autodesk. It's online. You don't have to download it. You don't have to pay. It's free. And it is based on constructive solid geometry. So it allows you to create complex models by combining simple objects. And I can show you here in a minute. By taking simple geometric shapes, you can add to them or you can subtract them. And that way you can create more advanced ones. This is great for hobbyists, teachers, kids, and designers. It's a great intro to 3D modeling and can kind of spark that interest. Another really cool thing about it is that it has full lesson plans for teachers or even yourself if you're kind of interested in starting with some basics. Some other things that are available, SculptFab. If you don't want to mess with the mesh, with like the vertices and the faces and the edges, there's great software that you can kind of sculpt. It kind of emulates sculpting clay. With this, you'll be able to like pinch, swirl, push the sculpting material in, flatten it, extrude it. It's pretty intuitive. It's a lot of fun. I recommend it. And this is kind of a file that I made real quick. You can see this starts taking shape of a face. But yeah, there's a lot of stuff you can do in there. Blender is a great software. It's free. It's open source. It does have a very steep learning curve because it offers so much things you can do. You can rig models. You can animate them. You actually can sculpt in that program. You can mess with lighting. It's also for video editing. So it's kind of a jack of all trades. It can do a lot of things, which might be discouraging for some people. But if you're interested in modeling, I would definitely recommend downloading Blender. It's free. There's nothing to lose. And because it's free, it has a great community online where a lot of people help with tutorials and kind of just like forums and help you get started. We also have Linda, or not Linda, it's LinkedIn. Through our database, you can learn some of this software through LinkedIn.com, LinkedIn Learning. So let's prepare a file to print. So Cura is what we use as a slicer. There's many slicers out there. Some of them are specific to a specific printer. But with things with Simplify and Cura, you actually can specifically tell it which printer you have. So it's not just for the Ultimaker series. It could be for Prusa, Creality, and then all sorts of printers. I don't know all of them, but yeah, there's a lot of settings in there that you can use. Oh, and another thing for modeling, a third way that you can get a model is by photogrammetry. So what this is, you can use software like Meshroom, not Mushroom, Meshroom. You can take multiple pictures, usually 60 plus. And then the way that it works is the software takes the pictures and it kind of like tries to figure out the measurements and sorts the pictures to create a 3D file from a 2D plane. You will need a lot of pictures for it to be accurate. If you're missing information, you can take pictures. If you have gaps in your model, or if you have things in the background that you don't need, you can kind of edit those. And I forgot to include a slide, but Meshroom is one of the free softwares you can get. You can get a trial as well for like a pro version, and then take pictures. You can take pictures of anything. Usually works better with smaller things. The larger things tend to have a problem. But yeah, that's something really cool too. You can work with. After you create your object from a real life thing that you've captured images of and create it into a 3D model, you'll also be able to export it into other modeling softwares and kind of manipulate it, add your own stuff to it, and just personalize it more. But sorry, back to the slicer. What the slicer does, it splits the object into layers. And then the reason it needs to do this is because Cura generates the instructions for the printer called G-code. And G-code is pretty much just like a text document full of information of what the printer needs to do. The printer doesn't understand the 3D model. It just understands the path that it's going to take on the X, Y, and Z axis. So this will have all the information about your quality of the print, the speed, the fans, and the path that it's going to take. Yeah, and here's kind of an example of how it slices it. It just does very fine layers. They're not going to be this wide, but it kind of splits your object into horizontal layers. So let's switch over to Thingiverse real quick, so you guys can see where we can download the files. We'll import them into Cura, and then we'll kind of talk about the settings in Cura. Oh, sorry, it was muted. I forget that once you share it, it mutes you automatically. So yeah, earlier Cura was, Thingiverse was down, so I downloaded a file before. With Thingiverse, there's hundreds of files that you can browse through, which people create and upload. All of these are free. Most of them are free for use, and they have kind of like the licensing here. So they do encourage you to kind of like modify their own file to make it unique, give credit, and it has like specialized settings for it. So, so you can be more successful in your prints. So earlier I downloaded this elephant, which we are going to work on. There it is. So this is what Cura looks like. It gives you a representation of your workspace. So in our case, it's the Ultimaker S5. So all of this is to scale. Here are your margins, these gray areas. I don't know if you can see my mouse. These gray areas are kind of like out of bounds. And as you mess with the settings, you either add supports, it'll start shrinking. So we can actually do that. No, it's not doing it. Okay. Yeah, this is I think it's a newer version. But yeah, before, once you added extruders and like supports from the second one, it kind of starts decreasing your build plate area. So from the top left to the right, we have here our open, which we're going to go ahead and click. Import our elephant file. And the reason why it's looking like this is, one, it's out of bounds here, like over here to the right. It's also way too big for our build plate. So here on the left side are going to be most of the options for editing your file. You can't actually add or subtract anything to it. It's mostly just scaling and positioning. So the first one here is the move. You can tell it specifically where you want it to be by adjusting the millimeters of the X, Y, and Z. So you can have more precise control of where you want your file to be. But we're just going to click and drag to the middle. Our second option here on the left is scale. You can manipulate everything individually. What I would recommend is just keeping everything uniform so it doesn't mess anything up. If you're wanting to increase the size, the height of it, let's just go ahead and change the Z information. So let's do 127. Should be about like 5 inches. And then here you can see that the file was decreased by, it is now 39.49% of its actual size. And if you did not keep this uniform scaling on, if you're trying to have more precise things, you can change it like that. The thing is, it's going to skew horribly. Yeah, and that's not what you want. So we're just going to keep everything uniform. Our next option here is rotate. For support structures, or if you're just trying to fit as many things as you can onto the build plate, this is going to be very helpful. So you can see here, you can rotate it on the X, on the Y, and on the Z. If you click on these little arrows, they'll automatically snap 45 degrees, or 90 degrees, sorry. Or you can just click and drag and rotate it freely. We're just gonna have our little elephant facing forward. And then another nice thing is if you have it in a wonky place, you can actually just reset it to its original place. Hit flat. If your model does not have a flat area, it will kind of try to snap it onto the place that it would have the most adhesion. So it would be the place with the most surface area. So if we go ahead and click it, it's trying to rotate. And right now it kind of sees that as being the most stable. But we can see that it's not. So our third option is going to be your friend. So with this, you can click and select any face that you want and it'll snap to it. So we want the bottom to sit on the build plate and we can just click on it and then just click on it anywhere and it'll automatically adjust to that position. There we go. And as we rotate it, you can see that there's red stuff underneath. And that's because Cura sees that it needs supports. Because we build layer by layer, we can't really print in midair. So this left leg right here is not going to be able to print, so it'll require supports for it. And then we can get into the types of supports and then a little bit of the settings for that. Okay. And then up here, most slicers will have predetermined material profiles. So once you pick your core, you can actually go into materials, and then it'll have all the materials that you can use. Of course, you can make your own custom, but once you select one, the settings for it change. It actually lets you know by color coding as well. So what this would change would be like the cooling speed, the temperature, if it needs the bed to be heated to a specific temperature as well, so it can help with adhesion. It would do all of that stuff for you. Go ahead and just change it back to PLA because that is our most common one. Okay, and then here on the top right are our profiles. Now these are predetermined settings that you can use if you don't want to mess with any of the more advanced settings. So here you can have the resolution. The smaller it is, the finer detail is going to be, the better it's going to look. It's also going to increase its print time. So that's kind of a trade-off. If you want a fast print, it's going to be lower quality. If you want a higher quality print, it's going to require thinner layers, which requires more filament and more time. And then our infill is everything that is inside and supports an adhesion. So let's go ahead and go into the more advanced settings. Let's do custom. And then once you're in custom, you can actually change it from like fine resolution, normal, fast, extra fine, and then those will change all the settings accordingly. So let's start with quality. One of the main things that affects the quality of your print is the layer height. The thicker the material is, the less quality it's going to have. And I have a little representation here. Let's go back to our slide.
Oh, Hector, I think you're muted again.
There we go. Sorry about that. Yeah. So on the left side, you can see that the very bottom one is our first layer. The more layers that you have, the better the resolution, because you'll have more time to kind of like transition gradually on your slope, on your curves, whatever details you have. It kind of gives it more detail options. With the one on the left, it has less layers, so it kind of has to just do what it can. So if you zoom into a picture, like a raster image, eventually you're going to see those pixels. And that's kind of what happens. It doesn't have enough space to smoothly line out your object, so it just has to have these little jagged edges. And then here we kind of have another representation of what that would look like. Our first one has a thicker layer extrusion, 1 millimeter layer height. You can see that it does take less time. It's 8 minutes, but you'll be sacrificing the quality of it. Because it's really fast and thick, it's not adhering properly to its previous layers. If your print is too fast, your previous layer is not going to have enough time to cool and solidify. So it's not going to have a solid foundation for your next layer to start printing. And then as we decrease the layer height, you can see that our print time increases, but our resolution becomes better. Eventually, it's almost really smooth here on the right. And then our next setting is the walls. So if you want your object to be solid and a bit more sturdy, you're going to want to increase the wall shells. It's it's two different terms depending on like what slicer you use. It can be referred to as walls, or it can be referred to as shells. I personally don't do one. It's really cool because it's a little bit translucent, but I haven't had any luck printing with it. So I usually do 2 or 3, and then that'll be good enough for your regular everyday prints. If you're wanting something a bit more sturdy, you can increase the number of shells. And then to also increase the durability of your object, you can increase the shells and increase the infill, which will make it more solid. And here we have, oh, let me go back. Here we have the infill. There's a lot of different options for infill patterns. You can also increase the density. These different patterns have different attributes. So some of them can decrease the print time. Some of them decrease the amount of filament that is required inside. And you can also kind of change that. And then some of them allow for flexibility. There's a lot of them. There's a ton of infills that you can experiment with. What I usually use is, let's see, it's the gyroid. With the gyroid, you can usually increase the strength while also kind of reducing the weight. And you might have different preferences. This is something that you want to play around with as well. One of the purposes for the infills is to provide supports for the roof. So eventually your print is going to come to an end, and it kind of creates a support so everything can be held together on the inside of your print and also on the roof of your prints. So the infill kind of supports the stuff on the inside. For external stuff, we'll need supports. Now we can do just regular PLA if you're using PLA for your regular object. These are called breakaway PLAs. They can use the same material, so if you have one extruder, you can use that. If you have 2 extruders, you can use PVA, which is polyvinyl polyvinyl alcohol, which dissolves, is water soluble. So once you have your print, if it's something that is very intricate, has a lot of detail, or it kind of has like hard to reach places, kind of like in the middle of this circle, polyvinyl alcohol, you drop it into some hot water, leave it there for a couple of hours, shake it up. It eventually starts getting soft and mushy. You can rip it off, or you can wait. It can take a long time, but eventually it'll just dissolve on its own. And then that is great. I was trying to model like the Blue Dome building, and I can show you guys here in TinkerCAD kind of an example of what you can do with TinkerCAD. It did not work great because I decided to use PLA, and PLA kind of just destroyed a lot of the details. PLA is also great if you want to do something small. If you're printing like Dungeons and Dragons minis, which we've had a couple of customers sent in to us, those would be great for PVA since it's a bit more delicate than PLA. PLA can kind of destroy the structure of your print sometimes, but then you kind of have to configure the settings. So different types of supports. You can have supports going all through the print. You can have them just touching the build plate. So it won't build support on top of your actual object. It can be working around it. If you do want to work around and kind of minimize the amount of damage that the supports could cause to your print, or if you want to reduce the amount of filament, you can do this tree structure. With the tree structures, you can kind of set the angling branches and then the paths. You can kind of have more control with it. It's a bit more of an advanced setting if you want to play with it. There's a lot of cool stuff you can do with it. So supports. Your object doesn't always require supports. Sometimes just changing rotating the object to a specific angle would work better. Like this open box. Instead of filling all of the inside with supports, we can simply just turn it over and it'll print up because it's not going to be printing anything on midair. These little circles here on the edges, you can get away with them. If they're small enough and not as steep, you can get away with them. You would probably have to experiment depending on your filament, play with the temperature, the speed, and the cooling. And then, yeah, like I said, usually lowering the temperature and the speed will kind of give it more time to solidify so it has a solid foundation to work on. And then for supports, we also have the 45-degree rule. It's kind of a rule of thumb. If it's more than 45 degrees, it'll probably need supports. If it's less than 45 or 45, you might be able to get away with it. But again, you kind of have to experiment and see what works for you. Sometimes it will work, but it just won't be aesthetically pleasing. So if it serves your function, your purpose, that is fine. But if you're working like on a model or jewelry or something like that, then you might want to use supports so it's not drooping or stringing. And then here you can kind of see an example of stringing on the right. This bridge can't really be supported because it's printing over midair. Depending on the distance that you're bridging, and of course your other settings, you might be able to get away with it, but it's just recommended to use supports. For this bridge, you can also just flip over and have it sitting on the flat side so you can avoid it. And then here, the ones that are laying down, this is what can happen. Lately, with our support materials or breakaway, this has been happening anyway. And that's something that I'm looking into because I'm not too sure what the cause is. But once you break away, and if you guys had any experience with this one, just let me know as well. But once you tear away your breakaway PLA, it kind of leaves this stringing at the bottom as well. So it's not working properly, but we have to find out. A way that you can test your printer and your filament and your settings, because everything is different, it kind of just depends on what you're working with. I recommend printing one of these. It's an overhang test. You can find it on Thingiverse. Once you print it, it doesn't require any supports, and it has a representation of all the degrees, on the print, and eventually you can kind of see that the quality starts degrading around 45. So anything after that, the numbers are going to get a little bit distorted. And if you flip it on the other side, on the bottom part of it, you're also going to be seeing some of the stringing that is happening with the bridge. So there's also other stress tests that you can do for your printer. So you can see some of the settings and what works for you and what to configure so you can have the best optimal settings. So build plate adhesion. There's multiple ways that you can do to make sure that your print sticks to the plate. Some of the things is adding painter's tape with or without a heated bed. A heated bed works great. It kind of helps the filament stick to it. But if you don't have one, you can also buy painter's tape or just regular PVA glue. Apply a thin layer, and it kind of helps stick to the first layer. After that, it prevents it from shifting, and it's just generally good practice. I always have a thin layer of PVA glue on there. Some of the other things that you could do if you don't want to add glue or painter's tape or don't have a heated bed, you can try to put a skirt. What the skirt does is it primes your material, and it kind of adds a couple of lines. You can determine how many lines you have around your object as well. But you can set the lines to make sure that your bed is leveled and that your filament is extruding properly. It's not going to be touching your print, so it's not going to offer that support. It's kind of just to make sure that everything is sticking well before it gets to the print. What I always do, just to make sure, because I don't want anything to go wrong, is to make a brim. The brim actually connects to your object, and again, you can kind of set how many layers you want around it. What the brim does, it kind of helps with warping. If you're working with like ABS or other materials like that, those kind of tend to warp around the corners, or if they start cooling preemptively. What the brim does is ensures everything is kind of just held down. And I always use it. I don't want to risk restarting a print because, as you know, printing can take a really long time depending on what you're printing. So I'd rather just not take any risks. Rafts. Rafts are built under your actual object. So it creates a grid with a roof and a bottom part. So it's useful for whenever you want to, whenever you have an object that is not completely flat, or it has like not as much surface area, so a little adhesion, you can create it. It will attach to your object, but you can easily just rip it off. It kind of serves as a plate, as a base for your print to work off of. Okay, let's go over to TinkerCAD real quick and kind of show you how that works.
Hector, we're muted. Perfect.
Sorry, that happens every single time. Yeah. So this is TinkerCAD, which is great if you are beginning to learn 3D modeling. It's very accessible. The user interface is very clean, simple. It's great for teachers or students. It has great applications. So let's go ahead and do a new design. And here is our plane. Here's our work plane. To manipulate the camera, you can use this block here on the top left. You can click on the words and it'll automatically snap for you. So here's the front, the top, the right side, and then we can go home. You can also zoom in by clicking the plus, zoom out with the minus, and then kind of have a flat view, which is useful if you're trying to get things evenly on the plane. Another really useful thing to use for the camera is if you're reorientating the camera, you can right click and move with the focus of the work plane. Same thing, if you click and hold the mouse, you'll be able to move the plane. But let's say we wanted to focus on just this cylinder. Right now, it's focusing all around the work plane. So we'll go ahead and click on your object. Click here on this little box, fit to view, and it'll zoom into that. So now once you rotate it, it's going to be focused on that. So you can kind of have a bit more control and see what you're doing better. This program uses basic shapes, which translates, like I said, to other modeling software, either computer-aided design software or software that's more aimed for artistic stuff, like Blender. So we'll drop our object. We're going to be working on a basic shape. Let's make a little pig. So we have our object. We can click on solid to change the color. The color for this is just kind of to help you see what you're working with. Once it gets exported into Cura, it's not going to see those colors because you're only going to be able to print in one color, unless you have dual extrusion or you swap out in the middle of the print. Here, the steps is kind of the resolution. If you reduce it, it reduces the amount of faces that it has. So it's not going to be a sphere anymore. If you're working with low poly art, which I love, yeah, that would be great to use. So we're going to go back to 18. Okay. So let's work with making a bit more of a complex shapes. So with the whole tool, you can make this an extract from a shape that you're working with. So we're going to go back into a solid with this little square right here. This is the height. You can click and drag, or you can click it and then set your own parameters for it. It all works with millimeters. Same thing with Cura. The sizes and everything, it's all millimeters. So let's go ahead and reduce it a little bit more. There we go. We're going to make another one. Let's actually just duplicate this. On the top left, you can click this little square with other squares behind it. We're going to duplicate it, and it does it right on top of the file. So I'm going to click and hold on this bottom right handle, and click and hold Shift, so everything stays with the same parameters. So 14 and 14. If you don't hold Shift, it's going to move freely, so it's going to get distorted. So for it to stay proportional, we're going to press and hold Shift. Okay, and then what we're going to do with this is we're going to make a little pig. So we're going to work on the nose. As you can see, it's hovering right above. I want it to be close to the actual object. What you can do is either drag it down, kind of get a measurement, or you can use this this work plane tool. What this tool does is you can apply it anywhere to the object, and it creates a new plane. So once you have your object, you can actually just snap things onto it. I'm going to go ahead and press D, and it drops it down to the work plane. we'll go ahead and make a hole. And then duplicate this. For your holes, you want to make sure that it is actually having an intersection with your other object. So we're going to make it go kind of like halfway down. With both of our holes selected, we can click our solid shape and then group here with Control G, or you can click on this icon to group, and it kind of creates those holes. And that's what we're going to use for a nose. We're going to reduce the size and then flip it. Here with these arrows, you can kind of see that you can click and hold. If you click and hold and go down to this inner circle, you can move it by 22.5 degrees, or you can do it by 1 degree at a time. We're going to click it. We're going to tell it we want 90 degrees. We're going to adjust it. And then probably decrease the size. And there we go. We have what is taking shape as our little pig. And then real quick, I know we're running out of time. We're just going to make a little eye for it. But this kind of just serves as an example of how intuitive the software is. It's easy to pick up, great to play with, but you're actually learning design and yeah, just design concepts. There you go. And then once you're done, you are going to obviously want to go back in. Oh, it's facing the wrong way, so it's -90. And yeah, after you clean it up, make sure that everything is touching together. You can actually export it as an object file, an STL file, or an SVG. If you wanted to design something and send it to the laser cutter, you can actually just throw it onto there. So yeah, those are the basics of a 3D printing and a little bit of modeling. If you guys have any questions, let me know. You can also email me hector.arizola@tulsalibrary.org. Yeah, thank you.
Thank you so much, Hector. That was wonderful. I loved that. Now I kind of just want, I think I get now why people watch like art streams of people messing around in TinkerCAD and Blender. That was lovely to watch. So before we officially end, I want to mention a few of our upcoming classes. So we have a digital literacy lab orientation that is going to be happening next Monday, the 20th at 11 here at Central Library. Hector, of course, has an intro to screen printing class that'll be happening on December 22nd, that Wednesday evening. It is full because who doesn't love screen printing? But many other classes coming up, including one on January 20th for 3D printing, which it seems like you all might be a little interested in. So,
yeah, and the classes are going to be a little bit staggered because we're going to cover like 3D printing, laser cutting, a little bit of the audio lab. So if you are interested, go ahead and sign up anyway. You're going to be added to a wait list. And if we have enough interest, we can just go ahead and like do that one next to kind of like address the people that weren't able to make it.
excellent. And thank you all again for coming to this talk. And thank you, Hector, for doing it. And I hope you all have a lovely Friday afternoon. Goodbye.
Thank you, everyone. Goodbye.